Before we start going over the first 2 pages, the little review pages, I want to review some vocabulary words. So I want all eyes up here. What is this first word? Go ahead and read it.
Polygon.
Polygon. Does anybody remember a good definition of what a polygon is? This would be back from 3rd grade because we haven't really gone over that yet in this classroom. Okay, so she's saying a shape that has different sides and different vertices is I think what you meant to say. So then by that, would this be, here's some different sides, would this count as a polygon?
Yes.
No.
I have some yeses and some nos. If you said no, what about it makes it not a polygon, or what do you think makes it not a polygon, Ethan? It has to say it again? It has to connect the sides. So if I did this, would that be a polygon now?
Yes.
Yes, that would be a polygon. So the polygon is a shape, and it's a plane shape. Not plain like boring, not plain like plane in the sky, but plane as in it only covers a plane, a 2-dimensional surface, meaning it can't come out. If I brought out what shape is this?
Square.
It's a square. It's a rectangle. And because it has this dimension too, we call it a rectangular prism because it's 3-dimensional. But polygons are 2-dimensionals, meaning flat. You can write it on your paper, you can write it on a board, you can write it on your desk theoretically, but it's flat. So it's a plane shape. A polygon is a plane shape. A plane figure. A plane figure. Now, obviously it's not just a plane figure. We decided it had to be connected, and we call that closed. So it has to be closed, which means where it started, it ends. Because this, if I did something like this, it looks like a TP. It's closed, right? But it's not where it started is not where it ends. It has to start and end at the same point for it to be counting as closed. Okay? So it's a plane figure. It's closed. There's one more rule that goes with a polygon. Does anybody know what the other rule that goes with a polygon?
Oh.
Is that a good hint?
Yeah.
Haley?
That has corners.
Okay, corners. Instead of corners, use a different word. Because that has corners. What about it is different though? Straights or segments, right? I'm going to write straight lines. So a polygon is a figure that's a plane figure, meaning 2-dimensional, that is closed, meaning it starts and stops at the same point. I did a circle, but it doesn't do a circle. Starts and stops at the same point and has straight lines or straight edges. Okay? Would that be a polygon?
No.
No, which rule did it break?
No straight lines.
Straight edges. It has curves. You can't have curves. Okay? Do you have a question?
So a polygon can be any shape without curves.
Right.
Closed.
And closed. So you can have 1,000 different lines that make this huge, bizarre-looking polygon. Why would 2 sides not work? 2 lines or 2 sides. Malia?
Because if you only have 2 sides, you can't close it.
Right. If you only have, no matter how hard you try, you're like, yeah, I'm curving, right? You can't make a closed polygon without curving it. So it has to be 3 or more. And then it's 3 infinite numbers.
A triangle is a shape that only has 3 sides and 3 corners.
Okay, instead of using the word shape, can we be more specific about what kind of... There we go. It's a polygon with 3 sides, and I like the last part, and 3 vertices. There you go. So knowing what a triangle is, what might a quadrilateral be? Right, and so it's a polygon with 4 sides and 4 vertices. We're using the word vertices and not corners, okay? Vertices is where 2 lines come together. Okay, so let's go ahead. Everyday things can model geometric figures. For example, the period at the end of a sentence models a point. A solid painted stripe in the middle of a straight road models a line. So when you're looking at a road and you see that line in the middle and it's straight, that represents a line. I also modeled a 3-dimensional shape by using a book. I did that a minute ago where we did a rectangular prism. We have a nice little chart here that will help be a good reference tool for us. A point is an exact location in space. I can put a dot. Where is that point? Right there. It's in that exact location. Is it over here?
No.
No, it's right there. It's an exact location in space. And in this case, that space is right here on my paper, right there. Okay? They also drew point A. I just drew point B. You can label your points so that if you're talking to somebody, they know what you're talking about. If I said point to point A in your book, you can point to point A. Right? If I told you to point to point B on my board, you could point to point B. You know exactly which one it is. What color is it? Purple. Okay? This is how I read it. I've just given you an example, point A or point B, and how you write it. You would write it like point A or point B. And the example, I guess, is not really that pencil. It's that point right at the tip of the pencil, right there. That's what they mean by the point. The next one is a line. We kind of talked about this already. What is a line? It's a straight path of points that continues without an end in both directions. So this line continues that way forever. And this line continues that way forever until they meet each other as they go around the earth and come back to each other, basically. It's an infinite set of points. What they mean by set of points is it's all of these points. Do you see that there's all these points on this line and they're all connected infinitely? Okay? Now, this line has been labeled line CB, and it's the line that contains point B and point C. Now, if I did this and called this point D, and then I drew a line, let's see if I can draw a line straight here. This line is line BD. Is it line BC?
No.
Because it does not contain what?
C.
It doesn't contain point C, so I can't call it that. All right, so up here it says this is line BC or CB. It doesn't have to be in alphabetical order. So it could be called line BC or line CB. And the way you show that is by putting the little tiny line above it with the arrows. You have to put the arrows to call it line BC or to call it line CB. Now the one that I drew down here, what is that going to be called? Line BD. So I'm going to call it line BD. Is that the only name I can call it?
No.
What else can I call it? Line
DB.
Line DB. And when I write it, this is how I say it. This isn't how I would write it. I would write it like this. Now I have a big fat pen, so it's going to look really big on my paper. Yours won't look that big. I can write it like that, or I can write it like DB this way. Okay? An example in real life is this line going down the center of the road. It's a nice straight line. It kind of goes on forever. You don't know when it's going to end. A line segment is a part of a line between two endpoints. Now this line ends. It doesn't continue on forever. It starts at D and it ends at E. Okay? We call that line segment DE or ED. D. You seen a pattern here?
Yes.
Okay. The way it looks when we write it is a straight line across with no arrows. And you can't see that very good up here, but I'll write it. It looked like this, just a straight line. I know that's a segment that starts at D and ends at E. Or I could write it the other way, and I know it starts at E and ends at D. Okay? An example is this line right here. That's a segment. Do you think this is a segment?
Yes.
Yes, it is, because they end. Okay? Those are all segments because they end. And I can label them. I can call this A, B, C. So from here to here would be called segment AC or CA. From here to here would be called segment BC or CB. And then you guys get the picture. Okay, we're going to do one more. All right, a ray. A ray is a part of a line that has one end point and continues without end in one direction. So it starts here and then it goes on forever, infinitely. So it's kind of like a combination between a segment and a line. So it starts here and then it goes on forever from G. Okay, so here's the difference with this one. When you call it by its name, it can only be FG. It cannot be GF. Does anybody have any thoughts why it can only be FG? Right. It starts at F. It goes through point G and then goes on forever. Okay? So ray FG specifically tells us it starts at what point? F. It specifically tells us that it starts at F. And then it goes through and goes on forever. And then again, you can't see it up there very well, but it would look like FG. We have the segment and it goes like this. I'm sorry, the ray. It has a specific starting point, so we don't put an arrow that it goes on forever in the other direction, and then we go on forever that way. Okay? An example, the little arrow on the one-way sign. It's this, that's the example. Draw and label JK. Now looking at your book, because you can't see very good here, it looks like this. I'll draw it. Looking at that, how would we say that? Line segment JK. How did he know that it's line segment and not line? Jaden.
There were letters JK.
Okay, and how did he know that it's line segment and not line? A line would look like this, but it doesn't look like that. Okay, so this shows that it's a line segment. Okay, so I'm going to draw a line segment, and to show that I know that it's a segment, I'm going to put some nice little dots, and I'm going to call those dots JK. Is there another way to name line segment JK and explain it in your own words? Who would like to share what they wrote? Malia. Lydia. Okay. So there is another way to write segment JK, and that's to write it as segment KJ. It means the same thing because there's no specific starting and ending point, so it doesn't matter. An angle is formed when two rays, we just learned about what rays are, when two rays are line segments that have the same endpoints. It's when they connect. I missed the word by. The shared endpoint is called the vertex. So in this example here, is it showing two segments or two rays? Rays. Shane, how do you know it's a ray? The arrows. So the arrows give you a clue that it starts here and goes into this direction infinitely. Okay? If it was a segment, what would be different? They would end with the dots. Dots and then ending. Okay. So this is what an angle looks like. What we call this angle is angle PQR, or angle RQP, or angle Q. And it looks like this. You draw a little like sideways angle. It doesn't have to be the same angle. So if my angle, because this could be an angle also, right? That's a very curvy angle, but that's an angle. When I represent it over here, I don't have to draw it like that. All right, we use the same symbol. It's always this little tiny caret thing. And then whatever you're calling the angle. I have a question for you. And I want you to think, can I call this angle QPR? So I think I know where she's going with it. She says you can do this because that's connected. And you can do it in the opposite direction because they're staying connected. But you can't do this one because all of a sudden now I'm not connected. Okay. And she's right that we can't do it, and this is why. You can name an angle by the vertex, which is the Q. In this case, they come together at this vertex. You can name the angle. When you name the angle using 3 points, the vertex is always the point in the middle. Okay? So if I'm going to use 3 letters, one of the letters in there's 3 letters. It's PQR and RQP. The middle letter has to be the vertex. And what Sophia was explaining by doing this is exactly why. Because if I call it QPR, like this is the angle I'm talking about. This one here. Not this one. So it's a way to show which specific, because this is I've kind of made a triangle like this, haven't I? This is a way to show this is angle Q, this is angle R, and this is angle P. I can also call this angle QPR. Okay, I start there, I go there, and I go there. That's the middle, so that's the angle I'm talking about. Okay, so the position of the vertex, where the angle is, has to be the middle of the letters, or the letter by itself. All 3 of these would work for that, but this would not. So he's asking, could I call this T, A, and R? Can I call it T, A, and R?
No.
Yes. It doesn't matter. Do I have to write them in alphabetical order when I write them? No. I'm going to write A, T, R, or R, T, A, so that they know that I'm talking about angle T. It doesn't matter if the letters are near each other in the alphabet, and they don't have to be written in order. Next one is a right angle. A right angle forms a square corner. Remember when we talked earlier about the perpendicular lines creating a square corner? That means if you took a piece of paper or something else and you put it into the corner like this, it should be a square. It should be that straight edge, right? That's what we call a right angle. It makes a perfect square corner. A straight angle forms a line. Kind of makes sense. If the angle is completely open and straight like this, it forms a line. This can be an angle. We can call that an angle. It's just a straight line. An acute angle. How many of you have heard that before? Acute. Okay, so an acute angle is any angle that's less than 90 degrees. Or less than a right angle. Sorry, we haven't got to degrees yet. Less than a right angle. So if it's basically smaller than what would be a corner, if it comes anyway in like this, it's acute. Okay? So this is an acute angle. I call it acute because it's small. Acute angle is a cute angle because usually small things are cute, right? An obtuse angle is greater than a right angle. So I could actually draw in my right angle. Okay, there would be my right angle. That's my corner angle. And the angle goes past that. That's what we would call an obtuse angle. So bigger than a right angle. And I know that you guys have seen this in 3rd grade, right? Okay, so this is a good review for you. So acute and obtuse and right. Activity 2 is classifying angles. To classify an angle, you can compare it to a right angle, which is kind of what we did here. I said compared to a right angle, it's smaller. Compared to a right angle, it goes wider. So you can simply put a right angle up against it. So if in your book, you're looking and you're trying to decide, gosh, I can't tell if that's a right angle or not a right angle. So if I'm looking at it in my book and I can't tell, gosh, I don't know if that's a right angle or an acute or obtuse. It's so close I can't tell. Take a piece of paper, or you can even take a Post-it. You're not doing it right now. Just fold it in half, and you've created a right angle. You can do it with this. If you know your paper straight, you can just use the corner of the paper. And then you can just take it and put it up against one straight line, one straight edge here, and see, is it bigger or is it greater than right angle or less than a right angle? Go ahead and tell me. Greater. So what kind of angle is it? Obtuse. Okay, go ahead and do yours. Now looking at angle B, can you tell if it's greater than or less than a right angle? It's less. So what do we call that? Ooh, this is one of those that I'm going to have a hard time. See that one? It's kind of close. Hard to know. So I'm going to take my paper and I'm going to put it up against one, and I'm kind of seeing that it looks like that other part's going to be hidden. So if I put this like this, it's still not very dark. I can see that it's, what do you guys think? Is it greater than or less than a right angle?
Greater than.
Oh no, it's
Less than.
it's hidden. If it was greater than, I should be able to see that other line, but I can't see it. It's hidden. It's gone, and it takes me a while till I can really see it. It is smaller. It is smaller than a right angle. It is smaller than a corner of a piece of paper. What about that one? It looks.
Right.
That's what a right angle should look when you put the paper up to it. So right angle. Now, you're going to see something like this, where there's a figure, and it says, name a line segment. Which one is the right answer? TV, segment TV. Is that a right answer? Yeah, it's a right answer. Is that the only right answer?
No.
Oh, why not? Yeah, there's 4, right? There's this one, there's the green one, there's the red one, an orange one.
I knew it.
Okay, so it doesn't say name the line segment as if there's only one. It says name a line segment. So you can pick one of those line segments and write it. I'm going to choose VW. Did I write it correctly?
No.
Who said no? So you're showing me this movement in the air. So you have to have a line across the top to show that it's a line segment. Is that the only right answer?
No.
You can write any one of your line segments. Okay, the next one says, name a right angle. Preston, what did you come up with? T-U-W, and that's this one. Those are 2 right angles. Who knows how that's supposed to look? Ronnie? A little angle thing.